Welcome back. In this lecture, we will be look at some auxiliary object-oriented principles. So we have covered all the fundamental concepts of object-oriented programming, the objects and classes, encapsulation, inheritance, abstraction, and polymorphism. In this one lecture, we will be looking at the related concepts called cohesion and coupling. So at the end of this lecture, you should be able to implement object-oriented program that adhere to the concept of cohesion and coupling. So cohesion. Cohesion means how closely the routines in a class that are connected together, or whether they are serving a central purpose. That means every method has a well-defined responsibility. So in other words, when we implement classes, you have to make sure they are not, doing random things. Every class has a well-defined responsibility, and all your attributes and methods should be in line with that the purpose of the class. So we say we need to have high cohesion. That means all the routines and methods are and the properties are aligned with the actual purpose of this class. So on the other hand, if the cohesion is low, we say it is not a good implementation. So if we have good cohesion in our programs, it will inherently help us to manage the complexity, because now we have a well-defined set of classes that know what they are actually doing. So here's a real-world example between good and bad cohesion. Now, if you think of a hard disk or CD-ROM, so if you want to replace your old hard disk with a new hard disk, let's say a desktop computer, is it easy or difficult? It's really easy, right? Why? Because the purpose of the hard disk is very well defined, and we can have another hard disk that does the same thing. And on the other hand, if we don't know what the class should know, it is like we call spaghetti code. So it does everything. So what will happen in the spaghetti code? Just assume you are trying to take one string of spaghetti from this dish. What would happen? It will mess up the whole dish, right? When you try to take one string of spaghetti, it will affect all the other spaghetti strings. So that is the exact idea of spaghetti code. When you try to change one place, all the other places get affected. So your code is very difficult to be maintained. So if you have high cohesion, that means well-defined classes that do a well-defined set of functionalities, then very easy to change the code whenever needed. So consequently, it is very easy to maintain the code. So here's a good example of cohesion. So we discussed about the math class earlier also. What does the math class have? It has a very well defined purpose. The purpose is to implement the foundational mathematical operation like square root, power, exponential, likewise. So it doesn't have anything else, only these methods. So it has a well defined responsibility, and everybody knows it. So we don't go there expecting to look at how to access a database, right? So when we hear the word math class, we know what is there. So it's a well defined one. So here's a hypothetical example, a silly class that has very bad cohesion. So what's the problem with this class? What are the methods it has? It has a method to print a document, and it has a method to send an email, and it has a method to calculate the distance between points. And there's another class where you can make pizza, and you can withdraw money and open database connection. As you can see, these methods, just by the method names, they are doing completely unrelated things. So do not have methods or functionality that are unrelated in the same class. First, identify what the method should do, the class should do, and add only the methods that serve the central purpose of the class, rather than having random methods that can do anything here and there. The other related concept is coupling. You know what the mean by couple, right? You connect. So that means in the object-oriented programming, how much the classes are connected. So if classes are too much connected, then when you change one class, other classes get affected, just like the spaghetti, right? So it's very difficult to expand or maintain your code because every time you try to do a change, so many dependencies come and very difficult to maintain. So how can coupling be there between classes? So if you create an object of one class inside the other class, if you create call a method of one class from the other class, that means a connection. That is what we mean by coupling. So if all the methods are, or all the classes are connected to all the other classes, that means there's tight coupling. So you can visualize, right? So it's like spaghetti code. So we can't disentangle. That means we can't separate out the class from the others because it is connected to all the classes in different manner. So very difficult to single out a class and modify it because the modifications will affect many other places in your code. So we say in a code coupling or between classes should be low. So here's an example, real world example of loose and tight coupling. Now, as if you use the previous example, the hard disk. If you want to replace the hard disk, very easy to remove from the main device, right? You just unplug it and you can replace. Why? Because it is lightly coupled. The connection is loose, right? In contrast, look at the motherboard. Now, if you want to replace the video adapter, can you easily do that? No. Why? Because video adapter is tightly added to this motherboard. So this is what we mean by tight coupling. Of course, in a motherboard, video adapter should be tightly connected. I'm just using an example. So now if just imagine the same thing. You have tight connections between classes and now you want to replace one class with some other logic. Now you can't directly do that because of all these relationships that are there. So here's an example of loose coupling. So as you can see, now we have a report class and there is a print class and there's this program class that has a main method, right? So what do we do? So inside the program class, in the main method, we create a report object and then we get that object and pass to the myReport. So and as you can see, another thing you have to understand is coupling and cohesion go hand in hand. So we should have high cohesion. When you have high cohesion, it automatically helps to achieve loose coupling. So on the other hand, if you have loose coupling, that means it helps to achieve high cohesion. So these are two concepts that go hand in hand. We say our code should be having high cohesion and loose coupling. So here, as you can see, the report class has a well-defined functionality. It can load the file from the hard disk and it can save a file to the hard disk. And the same with the printer. All it does is print. When given a report, it prints, but it does not try to access the hard disk or anything. So everyone has their well-defined responsibilities. And here's an example of a tight coupling. So the problem here is, so now if you look at the math params, it has some variables defined. And then in the math util class, it uses the math param, reference to the math param class. And in the main class, here also it has a reference to the math param. So there are two coupling phases from my main class to the math params and from math util to the math param. So in fact, you don't need both these connections. Just having one connection is enough, right? So in this case, if we pass the, if you want to reduce the coupling, what can we do? So one example we can do is, we can take the operand, math param operand in the main class, and we can pass it to the SQRT method in the math class as a parameter. Then the math class does not have to reference the math params operand attribute. So as you can see, we can easily remove this math param operand access from the math-util SQRT class method if we simply pass this variable from the main method. On the other hand, if you want, you can simply remove the math param operand equals 64 statement in the main method, and just since anyways SQRT is calling it, we can simply omit. So and if you compare this code with the previous code, now if you look at the printer, it will access the report, right? And but it does not create a report object. The report object is created by the program, and it takes a parameter. It does not create an object itself. It just takes a parameter. So that's the difference here. So here, rather than taking a parameter, it directly accesses. So it could have easily taken a parameter mathparam.operand into the SQRT method. So when you have bad cohesion, that means low cohesion and tight coupling, that is a classic example of spaghetti code. So here, as you can see, we have a report class that got printing, initializing printing, and everything. And then printed as loading report, checking report, so everything is mixed up. So this is very bad cohesion, and they are referencing each other. Tight coupling, low cohesion. So that is the end of this short lecture, and where we tried to understand the concept of cohesion and coupling. As we highlight, your code should have meaningful classes with very defined responsibilities, so it will have high cohesion, and you should try to minimize calling methods from classes unnecessary, so that it will reduce coupling. So in the next lecture, we look at some related concepts when we design and implement classes.